Hello, it is Thursday, May 21st. I can determine when variables cancel if there are either no solutions or infinite solutions. If there are no solutions, the equation is not equal. If there's an infinite number of solutions, then the equation is equal. So there's two types of questions you're going to see. You're going to see linear equations and you're going to see systems of linear equations for this. If the variable cancels out and the equation holds true, for example, if you end up with 5 equals 5, those are equal, then there are an infinite number of solutions. If when the variables cancel out, the equation does not hold true, for example, if it says 5 is equal to 3, then there's no solution. Basically, if it's the same equation, then it is infinite solutions. If it's the same variable coefficient but not the same constant, then it's no solution. So let's take a look here. If I go to solve this equation, I would bring all x's to one side. And this particular sheet, the way I created it, it's like baby steps leading up. So we're going to probably go through the whole thing or close to it so you can understand everything. And I end up with 4 is equal to negative 8. Well, my variables canceled out, so it's either no solution or infinite solutions. Does this equation hold true? No. Therefore, there is no solution. If the variables cancel out and the equation does not hold true, no solution. Here, if I go to solve this and I subtract 3x from both sides, I end up with 4 equals 4. Well, the variables canceled out. Does this equation hold true? Yes. So there's an infinite number of solutions. So again, if the variables cancel out, it's either no solution or infinite solutions. If once the variable cancels out, if the equation holds true, then it's infinite. If once it cancels out, the equation does not hold true, then it's no solution. So for what value of a does the equation blah, blah, blah have infinitely many solutions? Well, in order for it to have infinitely many solutions, it must be the same equation. So basically, the 5x's would cancel out, and I would be left with negative 2 equals a. A would have to be the same as negative 2, therefore a would have to be negative 2. You need the constants to be the same if it's going to have an infinite number of solutions. For what value of a does this equation have no solutions? Well, in order for it to have no solutions or infinite solutions, the variables have to cancel out. In order for the variables to cancel out, a is going to have to be 6. Because if a is 6, now the variables would cancel. I would be left with negative 1 equals negative 2. That would give me no solution. So again, for no solution or infinite solutions, you need the same coefficient in front of the variable. It'll be no solution if the constants don't match. It will be infinite solutions if they do match. In the following system of equations, what value of a does the system equation have infinitely many solutions? Well, in order for it to have infinitely many solutions, I need the two equations to be exactly the same. So looking at the positive 3y and the positive 10, in order to make it the same as the bottom one, or look at the other way, I would need to multiply this by negative 1. So I have ax plus 3y equals 10. I have 2x plus 3y equals 10. So in order for them to have an infinitely many solutions, I need them to be the same. Therefore, a equals 2. For the systems, just make sure you might need to multiply one of them by something at the beginning in order for the other pieces to be the same. I need these to be the same before I can look at those. In the following system of equations, for what values of a and b does a system have infinitely many solutions? Well, I see 20 on the bottom, I see 4 on the top. They need to be the same. So I'm going to multiply the top equation by 5. I have 5ax plus 5by equals 20. I have 2x minus 6y equals 20. So in order for these to have infinitely many solutions, they must be the same. So 5a must be 2, and 5b must be negative 6. So a must be 2 over 5, and b must be negative 6 over 5. Again, in order for them to have infinitely many solutions, they have to be the same exact equation. So I multiply one of them by whatever I need to get something to match, and then from there I compare the rest of them. This is pretty much the same thing, and this is pretty much the same thing as well. So I'm going to let you try those on your own. You know what? No, let's go through this whole thing together. So why don't you try number 7 on your own right now? I'll give you about 2 minutes, then we'll go over it. Then I'll give you a couple minutes to try number 8, and then we'll go over that. Okay, so in order for them to have an infinite solutions, they need to be exactly the same. So right now, it looks like I need to multiply the top by 2 in order for these to match. So I get 2x plus 8y equals 16. I get 2x plus 8y equals a. So again, in order for them to have an infinite number of solutions, they have to be the same equation. Therefore, a must be 16. Number 8, I want you to take a look at this. Now here it wants no solution, so it's going to be the same thing. The left-hand side is going to have to match up, but the right-hand side won't. This one's a little tricky, so let's just go through it. So in order to get the left-hand side to match, it's kind of like what we did. I have to multiply each equation by the other's coefficient. I'm looking at the y's because I don't have enough information to do. 5, 2. Right now they're the same sign, so I make one of them negative. So I get 5kx minus 10y equals 15. I get negative 6x plus 10y equals negative 12. So in order for these to cancel, basically these are going to need to cancel. So if I add 5k and negative 6, they have to add to equal 0. I get 5k equals 6. I get k equals 6 over 5. Because if these both cancel, then I'm left with 0 equals 3, and that is something that will give me no solution. Now, you didn't have to make the signs different here. You could have just multiplied by positive 5 and positive 2. I just want to show you what that would look like. If I did it as, if I just get everything positive, positive 5 and positive 2, that would have given me 5kx minus 10y equals 15. 6x minus 10y equals 12. And basically, these have to be the same. So I could have just set it as 5k equals 6 and gone that route. That might seem a little bit easier. As I was going through it, I was kind of thinking that makes it more consistent with the other examples that we did. And if you want to get no solution or infinite solutions, you need the same exact left-hand side, so that 5k and that 6 must be the same. So again, in order to get infinite solutions or no solutions, whether it's a regular equation or a system of equations, you need to get the variables to cancel. Once the variables are canceled, if the left-hand side equals the right-hand side, it's infinite solutions. If the left-hand side does not equal the right-hand side, then it's no solutions. Normally, I'd say your classwork/homework is to complete the worksheet. We just completed the worksheet. So your classwork/homework, I'm going to say, is practice. And then your quiz will be to reach out to me or Ramon if you have any questions. Again, a very, very common SAT question. And yep, reach out to me or Ramon if you have any issues. And I hope everyone enjoys the rest of their day.